Hello everyone. Astrophysicist Martin Rees takes a fresh look at the question of whether we live in a multiverse, meaning our universe is part of a multitude of universes. It is easy to imagine other universes, governed by slightly different laws of physics, in which no intelligent life and no complex organized systems could arise. But are there really other universes beyond our own? This is a question that astrophysicists have been trying to answer for decades. However, it proves to be difficult. While we can confidently trace cosmic history to 1 second after the Big Bang, what happened before that is harder to evaluate. Our accelerators simply cannot produce enough energy to reproduce the extreme conditions that prevailed in the first nanosecond. But we expect that in that initial fraction of a second, the key features of our universe were imprinted. The conditions of the universe can be described by its fundamental constants, fixed quantities in nature, such as the gravitational constant, denoted as g, or the speed of light, denoted as c. There are about 30 of these constants, representing the dimensions and forces of parameters such as particle masses, forces, or the expansion of the universe. But our theories do not explain what values these constants should have. Instead, we need to measure them and input their values into our equations to accurately describe their nature. The values of the constants fall within a range that allows for complex systems like stars, planets, carbon, and ultimately humans to evolve. Physicists have discovered that if we were to adjust some of these parameters by just a few percent, our universe would be devoid of life. The existence of life, therefore, requires some explanations. Some argue that it is just a lucky coincidence. An alternative explanation, however, is that we live in a multiverse where different physical laws and different values of fundamental constants exist. Most of them could be completely unsuitable for life, but statistically speaking, a few universes should be friendly to life. On the other hand, physicists wonder if the Big Bang was a singular event. The inflation theory, which suggests that the early universe went through a period where it doubled in size every trillionth of a trillionth of a trillionth of a second, has real observational support. It explains why our universe is so large. But physicists like Andre Linde have shown that, based on specific but plausible assumptions, there could be an eternal production of Big Bangs, each giving rise to a new universe. String theory, which is an attempt to unify gravity with the laws of microphysics, assumes that everything in the universe is composed of tiny vibrating strings, but it assumes that there are more dimensions than the ones we experience. These extra dimensions, it suggests, are compacted so tightly that we do not observe all of them, and each type of compactification could create a universe with a different microphysics. Thus, other Big Bangs could be governed by different laws. Recent research suggests that there are universes that are even more conducive to life than ours. However, most tuning of the physical constants would result in many universes being lifeless. Critics sometimes argue that the multiverse is unscientific because we can never observe other universes. However, physical reality at its deepest level could be so profound and different from what we currently believe that it would take us thousands or tens of thousands of years to decipher it. Yet, there is no reason to dismiss the multiverse as unscientific. Other similar and interesting videos can be found right here on the final screen and on the links in the description. Thank you for watching and see you next time.